All right, this one we're talking about collecting sample data. Reason is sample because we don't know how many of the population is going to be. It's just maybe too big for it. Ooh, that's a little bit too big. There. Collecting sample data. If sample data are not collected in an appropriate way, the data may be utterly useless, and no amount of statistical torturing can do any good for it. So this is the most important. Well, deciding what you're going to study, how you're going to study, what questions you're going to put in the questionnaire, all this stuff takes a lot of time. And you have to analyze each part of it. You have to look at the viability, the efficacy of this survey. But if you collect the information wrong, all that work you did is useless. Case in point, when that researcher was influencing the people by their eyebrows or their movements, when you can bias the results that way. Part one, the basics of designing an experiment and collecting sample data. The gold standard. Randomness with placebo and treatment groups is sometimes called the gold standard because it is so effective. Okay, we talked about placebo. What is a treatment group? We Well, those are ones. There are two groups. You have, in essence, in every group, you have a control group and a test group. The placebo group has the fake medicine. So they're going to keep on going the way they normally are. But then you have the treatment group. Those are the people who have the actual new medication to see if it works. A lot of times when they do medicines is the most popular one. The fewer people that know who's the treatment and who's the placebo group, the more accurate you'll be. So that's why the doctors who are in charge of these researches don't tell anybody. They'll tell the nurses, this is medication for these patients. And they'll put them in specific cups and stuff that only the doctor knows what's in those cups, actually. Nurses go in there and give them. The reason for this is because there are a lot of sympathetic reaction. A nurse that feels sorry for one patient could say, take this instead. This is the medicine. The other one is sugar tablet. The second that nurse did that, the whole experiment is useless. But that's instead of putting the nurse through that torture, that's why the doctor said, no, I'm not going to tell anybody. Only we know who gets what. The definition of placebo is harmless and ineffective pill, usually made of sugar, and used to test the results of a treatment variable, the actual medicine. Example one, the Salk vaccine experiment. Salk invented the vaccine for polio many years ago. That's why polio doesn't exist anymore. Well, I would say it's come back, but it used to be exterminated from the human populace. But because some people don't believe in taking medication for anything, it came back. In 1954, an experiment was designed to test the effectiveness of the Salk vaccine in preventing polio, which had killed or paralyzed thousands of children before then. By random selection of 401,974 children, randomly assigned to two groups. 200,000 were given the treatment of the new injection of the new medicine, and 201,000 were given placebos. You see the effect now? Why it's much safer if the nurse doesn't know who's getting what? Because they're talking about children here with polio. You want to save them all, but we really can't save them all because we don't know if it works or not, or if it gives other symptoms. So the children are assigned to these two groups. Among the children given by Salk vaccine, 33 later developed paralytic polio. These are the ones given the vaccine. And among the children given a placebo, 115 developed paralytic polio. It would be far better to observe past crash results to understand the effect of driving while texting. But that's not. But what do you think? Is that vaccine worth it or not? Yeah, because only 33 of them who took the medicine got polio. 115 that didn't take it got polio. So even if it was only half, I would rather take that chance with my kid. In an experiment, we apply some treatment and then observe the effects. That's what an experiment's all about. You interject a treatment into a group, and then you observe the results. And those people are called experimental units, or subjects. In an observational study, we observe and measure specific characteristics and don't try. For example, a anthropologist who just discovered or who found a new tribe of pygmies in Brazilian rainforest. There's so much of the stuff that in the world we haven't even found. They're finding these tribes of people all over the world that never existed before. So instead of going into and observing them, they stay on the outer bounds of their village and try to stay disguised and observe how they live and they react. So because if the person was to go inside there, would that person's present change the way those people live? Yes. If you were taking a test and I was sitting right in front of you, staring at you, as opposed to not staring at you, not even being in the same room, would that affect you differently? Yeah. So by being observed, we're looking at different effects of different people. Ice creams versus drownings. Observational study. Observe past data to incorrectly conclude that ice cream causes drownings. Based on the data showing that increase in ice cream sales are associated with increases in drownings. Yeah, exactly. The mistake is to miss the lurking variable of temperature. If it's hot outside, are you more likely to eat ice cream? If it's hot outside, are you more likely to be inside a pool? So by looking at that, says then by taking ice cream, you're going to go swimming. No, that's what their mistake was. Failure to see that temperature increases, ice cream sales increase, and the more people who swim, the more drownings are going to be, whether they ate ice cream or not. So it's the same as I'm saying, after you eat, wait 30 minutes before you exercise. No truth in that whatsoever. No truth whatsoever. Case in point, you see a lot of marathon runners eat while they're running to get their energy back. If they waited half an hour, they'd never finish a 26-mile race. An experiment. Conduct an experiment with one group treated with ice cream and another group no ice cream and see what happens if they go swimming. So your observation is seeing if anybody drowns. Not helping them, but to see if they drown. Design an experiment. A good design for an experiment includes replication, blinding, and randomness. By replication, every experiment that's worth its weight in paper has to be able to be replicated and get the same results. Because if you do a study and you claim this, then other people in the world have to do the same thing and get the same results. Your results are, you're trying to make it for the world that you're examining. Blinding is used when a subject doesn't know whether he or she is receiving the treatment or not. There are other times where blinding is not really necessary. For example, in education, you will have, I'm going to do one in the very near future in a couple of my algebra classes, not ours here, but with dual credit students, to see if artificial intelligence as an auto grading mechanism really increases students' understanding and grades in a math course. Because when I think about it, when you do a math homework online, what kind of answers do you put in there? You just type in a number, don't you? That's it. Or if it asks you to draw a graph, it gives you a type of graph and you just put 2 points and it'll draw a graph for you. As opposed to if a student was to draw a graph and they take a picture of that graph and let the computer tell me if it's right or wrong. There's a big difference there. As opposed to now, instead of just seeing the number, I want to see the entire work. Which one's going to be better for the student in the long run? Knowing what they did wrong and where they did wrong. Let the computer tell me that. The knowing the why is important, because when we start doing numerical examples in this class and you give me an answer, I'm going to ask you why. You give me an answer, I'm going to say why. Why is that the answer? How did you get that? So just spitting out the answer, no, just reading a number off a calculator doesn't mean anything to me. I want to know why that's true. So in Salk's experiment was a double-blind experiment. A double-blind experiment is when two instances are unknown to the subjects. In this case, in the Salk experiment, the children being injected didn't know whether they were getting the placebo or the vaccine. And the doctors who gave the injections and evaluated the results didn't know either. In another case, somebody knew, and the nurses or the doctors who gave the medication didn't know. Remember I said earlier, the fewer people that know, the better it is. So everybody's fat, dumb, and happy thinking, okay, everybody's getting this treatment, so everybody's gonna get fixed. And that's what the whole experiment's about. Double-blind experiments are usually the best type because, again, the less chance of mistakes there. Codes were used so that researchers could objectively evaluate the effectiveness of the salt. Okay, coding is, if it was 0, then it's a placebo. If it's 1, it's a vaccine. But nobody knows what those numbers really mean. Randomness, to be honest with you, this is another difficult part of researching. Randomness. Assigning people to groups. Think of how random that is. For example, if I asked you to write down 4 numbers between 0 and 10, randomly, what does randomly mean? Not out of order. Randomly means without thought. Like if you roll a die, does it think about what's going to roll on? No, it just happens. But think of how hard it's going to be for you to write 5 numbers without thinking about it. Because the second you start thinking, well, I can't put a 5 again because I just used it. Once you think that, it's over. The test is ruined. So randomness in mathematics, which in this class I'm gonna give you a sheet that's called a random number generator. It's 4 numbers in like 10 rows and a whole bunch of columns, in 10 columns and a whole bunch of rows. We use that so that you can start at any one place, and going from there, you'll start picking numbers. You start getting numbers. It'll tell you what's right down. That'll make it random. Because the moment you put any thought behind it, you're done. It's no longer random. Selecting people. That's why people say, okay, this side of the room, you're doing this side is this. There's no thought about who's where. The only people who thought about where they're sitting are the students. And the students have no indication of what the test is going to involve. So randomness is very important, and sample size. Other sampling methods. In addition, there are other sampling methods that we commonly use. Systematic sampling. Systematic sampling is when we select some starting point, and then collect every nth number. Which this I'm showing you this random number generator, the sheet. We're going to pick any number, and from there, pick every third number. So 1, 2, 3, that number. 1, 2, 3, that number. It's totally random. Nobody even guessed what the next number is going to be. Convenience sampling, when the data is very easy to get. That's lazy, but that's what we do. We get whatever is the easiest way I can get it, let's do it. Stratified sampling. What is a strata? Well, if you look at the clouds, a lot of times they're stratified, which means they're layered. So stratified sampling is where we subdivide the population into at least 2 different subgroups. And so the subjects within the same subgroup share the same characteristic. Then we draw a sample from each subgroup. So what that is you're mixing it up, and then picking it up, then picking from there. So there's different levels of randomness. And then cluster sampling is when we divide the population into clusters and then analyze each one of those. And we can select one of those clusters and satisfy that one. Then we randomly select some of those clusters and choose all members from that cluster. So, for example, here, my clustering for this classroom would be each table. And then I would say, I'm gonna pick every third table. So 1, 2, 3, that one, 1, 2, 3, that one, 1, 2, 3. So that way, I don't know who's gonna get picked. You don't know who's gonna get picked. So I would then use your information on test grades to see what it is for the class. Words in surveys can affect results. Words are very dangerous. Pew Research Center pollsters conducted experiments to better understand how wording can affect responses. In a survey, 1,505 adults in the United States, half of the respondents were asked about finding jobs, while the other halves were finding good jobs. For those finding jobs, 33% they found the jobs were difficult to find. Of finding good jobs, 45% said that good jobs were difficult to find. What's different there? The word good. What does good mean? How do you interpret the word good? Well, then you would say a satisfying job. A good job, people, when I say good job, what does it mean to you? Not desired, because let's say your job, a desired job is what can I get paid for doing the least amount of work? That's typically what people want. I want to do something I enjoy. Well, nursing, that's a very noble profession. Is it enjoying? Is it enjoyable? As a whole, you can say yes, because it makes you feel good. But when you go to work and the first thing that happens is somebody throws up all over you, is that enjoyable? No. So enjoying your job is not the same as a good job, as opposed to just a job. So you would think, again, it's that's exactly it. Is how do you the word good is subjective. Everybody in here has a different idea what a good job means. I went to law school thinking I want to be a lawyer. A year and a half later, I said, I don't want to do this, because you start talking to lawyers, you start seeing what they really do. What you see on TV is not being a lawyer. What you see on TV is being an actor. Which, if you're interested in law, go to one of the courthouses downtown Dallas and sit in on a court case and see exactly how boring it really is. Okay, that's what you see. And that's not the law. When you work at a law firm, that is usually one of the people who are higher up, that have been there much longer than you. They get to go to court. They get the high bucks. You know where majority of the people who hired as lawyers at law firms where they work? Libraries. They spend all their time looking at for previous court cases, previous information. They gather all the information that the trial lawyer is going to use. So you're spending $75,000-$80,000 a year going to law school just to be a clerk and do legal research. That's why there's about 35-40% of the lawyers are quitting the practice every year. So yeah, and that's fortunately I got out before I made a huge mistake. So I'd much rather be with people and not have to worry about other stuff. Yeah, so it's using the words that you choose is good, satisfactory. My perfect job would be sitting on a beach drinking Mai Tais and doing nothing and getting paid for just sitting there drinking Mai Tais and surveying Mai Tais or surveying drinks. Being a food critic is a perfect job. Going around doing what you like eating and writing about it. What did you think of the service? What did you think of the tables? What did you think of this? You just have to do one little report. And then if people know you're a food critic, they usually give you better service and better food. So that'd be my job. Multi-stage sampling. Professional pollsters and government researchers often collect data by using some combination of the preceding sampling methods. They do that just to get a wider range of accurate measurements. Example, U.S. government's unemployment statistics are based on surveys of households, and it is impractical to personally survey each household in a simple random sample because they would scatter all over the country, making it nearly impossible. Instead, the U.S. uses census to do this. And besides sending out the census, they also send people door to door to ask questions. You get it mailed, and then they verify it again with people going by door to door to door. It's time restrictive and very expensive to do that, but they try to get the best information they can. A recent survey incorporated a multi-stage sample. This is their steps. The entire United States is partitioned into 2,025 different regions called primary sampling units, PSUs. The PSUs are usually large area metropolitans, large counties, or a combination of smaller ones. Now, where they came up with 2,025, I don't know. Those 2025 are subdivided into 824 different strata. So you have each part. Now, each part is cut up into different strata. Each of those 824 different strata, one of the primary sampling units is selected so that the probability of selecting is proportional to the size of the population of each sampling unit. Think of that now. Again, in each of those strata, one of the primary sampling units is selected so that the probability of selection is proportional to the size of the population in each primary sampling unit. That right there would make you stop reading. So what you're doing there is you're trying to find the best strata in that primary, the PSU, so you get the best information possible. Among the 824 PSUs, census data are used to randomly select about 60,000 households. The responsible person of those 60,000 households are selected and interviewed about employment status. Anybody 60 above, anybody 16 or over. So you see how much time and effort it takes. That's the reason they do it once every 10 years. Human Project. Started in 2014, the Human Project is a prospective study in which 10,000 New Yorkers will followed for decades. The goal is to provide new insights and understandings on how our biology, our environments, our behaviors interact to determine our health. think about this. To determine how our biology, our environment, and our behavior determines our health. So what does that mean? Our biology. What does biology mean? Our biology. Our physical strength, how we're made up. Our environment, where we live. And how we behave. Our behavior is a mental issue as well. So how healthy are the people who live in downtown metropolitan areas, like downtown New York? How healthy do you think they really are? They may enjoy it. They love it. Saying, I can go shopping. I can do everything. I don't need a car. As opposed to people who live out in the country, who live on 50 acres of land. Or even 10 acres, 2 acres, just so your neighbor is far enough you can't really see them. In 1972, in Germany, where I lived there for a while, the Olympics were held. After the Olympics, they figured out, okay, what are we going to do with these apartment complexes that all the athletes, reporters, and everybody else, what are we going to do with it? Because think about it, when they have an Olympics, they have to build all the surrounding infrastructure for everything, for all the people who work the Olympics, the people who participate, the coaches. So you have a huge apartment complex. They called it the Stone City. What they did is the researchers started thinking, well, let's see what happens. Let's observe the people that live there now. The level of crime, how many unemployment people we have, the homelessness, and see how they behave. And that experiment is still going on to this day to see how people behave and grow in a confined area with no trees, a concrete city. NASA is super interested in this because they're talking about making space people colonies on the moon and on Mars. And think of what that means. It sounds, how many of you would like to live on the moon? Chickens. I would go in a heartbeat. If NASA would let me fly to the moon or Mars, or even fly off to explore wherever it takes us, I would go in a heartbeat. And how big do you think the apartments you're going to live in on the moon are going to be? Are they going to be the same as you live in now? No, because they don't have that much material to build things with. Space is of the premium. Don't believe me? Look at a Navy ship, like an aircraft carrier or a submarine. You have 2,000 people living on a submarine, and they have to be people working 24/7. So that means they share the same beds. They take turns when they sleep. They take turns showering, they take turns eating, and everything like that. So that's what they're looking at here. But anyway, it's a very interesting hypothesis. How will people behave? Are their healths related to where they live, how they live? Beyond the basics of design of experiments and collecting simple data, observational studies. We talked about this earlier about the anthropologists in the jungle researching a new colony they've discovered. Here's a definition of what this is talking about. Again, we could look at this one. Here, what it means: observational study. When are observations made? Past period of time, one point in time, forward in time. If it's past period, it's retrospective. If it's one point in time, it's a cross-sectional study. And if it's in the future, it's a prospective study. And here are the definitions. In a cross-sectional study, which is on the one time, data are observed, measured, and collected at one point in time, not over a period of time. So it's a snapshot. Retrospective, case control. Data collected from past time period by doing back in time through experimental of records and interviews, which is really what most of the today researches are made of both of those. They see how like students, how they scored in the past and see how they're scoring now. And they're making future predictions. In the prospective study, data is collected in the future from groups that share common factors. These are called cohorts. A lot of colleges now and universities now have cohorts. When you go, we don't have it here, but if you go to university, like at A&M or Austin, you get put into a cohort as a group. That cohort now is students who have the same degree majors, start school at the same time. So you go through school as a group. The benefit of that is you get to know the people around you. And you get to share information. You get to be friends. As opposed to now, we go to every class, you don't know anybody in there really. I mean, think of how much time you get to spend with other people in this class. Very little. But think about it, if everybody in this class knew that you're gonna have the next class together and the next class together, eventually you'd make small groups of friends, study groups. So if you missed a day of class, then your friends would catch you up. So cohorts are the model of choice for future learning activities. Experiments. In an experiment, confounding occurs when we can have this, see some effects, but we can't identify the specific factors that caused it. Ice cream and the drowning. So that's confounding, where multiple things happen and we can't associate them. See also the bad experimental designs illustrated below. We're going to do that next. Because the treatment group consists of women, so there. If you have a treatment group of just men versus women, why is that a bad design? There are a whole bunch. I don't care what people say. No, men and women are not the same. Don't believe me? Take a biology class. So just splitting them up and having the same treatment. So we have, if you're looking at polio and you separate from men and women, that's not a good design, because if you want to see if this medicine works for everyone, not just one group of people. Completely randomized. What this means is you'll put them in strata, and then from inside each strata, you'll pick random people. Randomized block design. So within each strata, you'll take when we cluster, there should be more of a clustering where you have different clusters of people and you pick different clusters or groups inside those clusters. Matched pair design. This is a before and after. The same people before and after to see it work. In designing an experiment to test the effectiveness of aspirin treatments on a heart patient, we may look at blocks of men or a block of women, or look at age groups or ethnic compositions. Because all of those have very dramatic differences when it comes to health and physical makeup. Randomized block design uses the same basic idea as stratified, but randomized block design are used when designing experiments or used for surveys. Matched pair design are when you compare two treatment groups, the treatment and placebo group, by using subjects matched in pairs that are somehow related or have similar characteristics. So you have two different groups and you match people within those groups that are similar in attributes. Twins. Before and after in twins. I can't tell you the number of experiments that have occurred for twins. It's amazing the similarities between twins. They could be other parts of the world, and you look at their houses, they're almost identically designed. What they wear, what they eat, almost identical. Rigorously controlled design. Carefully assign subjects to different treatment groups so that given each treatment are similar in ways that are important to the experiment. This is when you control who gets put where. This can be different. difficult to implement, and are often we can never be sure how they accounted for the selected values that we reflect. So how accurate are how we put these people together? How accurate is that? Did that have anything to do with it? Sampling errors. We talked about this last section, but here we'll talk in detail. When good sampling methods will result to good results. Bad sampling will result in bad results. And we have to do everything we can as researchers, as statisticians, as science researchers, to make sure that these don't happen. A sampling error, or random sampling error, occurs when the sample has been selected with a random method, but there's a discrepancy between a sample result and the true population result, such as error results from chance sample fluctuation. Again, a sampling error is if it's a random sampling error, you had no control over it, it just happens. Non-sampling error is the result of human error. This can be fixed, including such factors as wrong data entry, computing errors, questions with biased wording, false data provided by respondents, forming biased conclusions, or applying statistical methods that are not appropriate for the circumstances. All of these are man-made. Most of them, if not all of them, are intentional. Wrong data entry, that could be intentional. Or it could be by mistake. The person was confused or distracted. Again, that's intentional because they chose to be distracted and keep on working instead of trying to do one thing at a time. Computing errors. That's not intentional. That's just you may have used the wrong formula for what you're looking for. Questions with biased wording. That's why before you ever start your study, you have to make sure your surveys, your sampling tools are correct. You test those before you test them on people. False data provided by respondents. Intentional. They know the respondents knew that was fake. Or applying statistic methods that don't apply. That's just bad planning on the plan of the person doing the study. Before you do the study, you should know what kind of analysis you're going to do at the end. Non-random sampling error is a result of using a sampling method that is not random, such as using convenience sampling or voluntary response. What do you think voluntary response sample is? Voluntary response sample. Yep. People volunteer. That's why when they go to malls or stores, they pick certain people. 3 people can walk by, 1 person can be chosen. It's not really random, really, because if you observe the people who are taking the surveys, they will, a lot of times when they get bored, they'll pick people that they want to talk to. So they're influencing that by selecting people they want to talk to, not people that'll represent the society. And that itself is ruining the whole design. Experimental design, much more thought and care than we can describe in this so far, because there's so many things that go on. So fortunately for us, our experiments are going to be very low-key and not require that much, because we're going in a long semester, I'd say, okay, let's do a survey. You guys each put together your group put together a survey. You got in the hallway between classes or in your next class or whatever, and you collect data. And then we'd analyze that data. We talk about, is it valid or invalid? How'd you do this? And then we do a complete study for that. But since nobody's walking around, really, there's few classes. What we're going to do, again, our studies are going to go on your cell phone usage. And then I'll show you how to get your data from your bills. And you get it from online also. Okay, that's it for chapter one.